Okay, we're continuing with more example problems that involve the general definition of trig functions. So not the unit circle definition, not the SOHCAHTOA definition where you're just looking at a general right triangle. The definition that's similar to the unit circle, except the radius is not 1, it's just any radius. You can pick any radius you want. No matter what radius you pick, you're going to get the same trig values for any given angle theta. All right, so let's get started. An equation of the terminal side of an angle theta in standard position is given with a restriction on x. Sketch the least positive such angle theta and find the values of the 6 trigonometric functions of theta. Okay, so in the previous video, we worked problems that were similar to this, except we were given a point P. Here, they're giving us an equation of a line with a corresponding restriction on the domain of x. And so what does this mean? Well, all right, this is the function y is equal to minus 2x. We can graph this, so this is going to go through the origin. The y-intercept is 0. Each tick mark is 1/2, so down to 1, 2 over 1, down to 1, 2 over 1. So there's the line y is equal to minus 2x, but we're restricted to x is just greater than or equal to 0, and this goes off to infinity. Okay, so now this constrains the angle theta. Here's the angle theta. Measured from, this angle is measured from standard position in the positive direction. In the problems in the previous video, we were given a point, and so we could connect that point to the origin to get this line. But here we're not given a point, we're just given a line. Well, to apply the general definition to get trig functions of this angle theta, because now this is a specific angle theta, it's not just like a variable, this is a specific angle. You know, we're not going to be able to figure out what the angle is. We don't have the skills yet to actually find this angle, but we can still find trig functions of this angle. This is a specific angle. It's constrained by this line. However, we don't have a point, but what we can do is pick any point on this line. The point we pick doesn't matter. So what we'll do is pick x is equal to 2. So that means y is going to be equal to minus 4. Okay, so we have this point. Now we want to create a right triangle where this is the hypotenuse going from the origin to this point, and the perpendicular angle is adjacent to the horizontal axis. Okay, now we know the coordinates of this point, so we know the side lengths. But we want to, if we have a negative value of x or y, we want to put that it's negative. So the point we have, this point here, this point P, is, we chose x was 2, so that means y is minus 4. So this leg is plus 2, and this leg is minus 4. Next, we want to solve for the hypotenuse, which is called the radius. So r is equal to the square root of x squared plus y squared, so 4 plus the square root of 4 plus 16, square root of 20. 20 is 5 times 4, so we've got that r is equal to 2 root 5. Okay, so now we're ready to solve for trig function values of this angle theta. What we do is we come to the angle within the right triangle. There's 2 acute angles. You go to the acute angle that has vertex at the origin, and you do the SOHCAHTOA. But you just keep in mind that you could have side lengths that are negative. In reality, the side lengths of a triangle are never negative, but for this general definition of trig functions, you can have negative side lengths. But just remember, we're not evaluating the trig function values of this angle. We're talking about theta, but that's just the method we use. We come to this angle and do the SOHCAHTOA. So the sine of theta, now we come to this angle, is opposite over hypotenuse. Opposite is minus 4. Hypotenuse is 2 root 5. So that's going to be minus 2 over root 5. Now they want us to rationalize, so we're not going to have a radical in the denominator. So root 5 over root 5, you've got minus 2 root 5 over 5. Okay, now the reciprocal of sine theta is cosecant theta, cosecant. And so we just flip this, but we don't want to have to rationalize again. So let's come back here. So sine is opposite over hypotenuse. So we're going to do hypotenuse over opposite. That's 2 root 5 over minus 4. So that's going to be minus root 5 over 2. All right. Cosine theta is adjacent over hypotenuse. So 2 over 2 root 5. That's going to be 1 over root 5. Right? So this is positive. So now let's rationalize this. That's root 5 over 5. Okay, secant theta is the reciprocal of cosine. So let's just come here. Instead of adjacent over hypotenuse, we're going to have hypotenuse over adjacent. So 2 root 5 over 2 is root 5. Okay, tangent theta is equal to opposite over adjacent. Minus 4 over 2 is minus 2. Cotangent theta is adjacent over opposite. 2 over minus 4, that's minus 1/2. Okay, let's go ahead and plot this line based on this domain restriction. We need the domain restriction, otherwise the line is going to extend into 2 quadrants. And so which creates 2 potential angles. So you need the domain restriction. All right, so adding 5x to both sides, dividing both sides by negative 3. Okay. So rise over run, but we need to go in this direction. We can't, the x has to be less than or equal to 0. So we can do plus 5 in the y, 1, 2, 3, 4, 5, and then minus 3 in the x, 1, 2, 3. Plus 5, 1, 2, 3, 4, 5, minus 3, 1, 2, 3. Okay, now this fully constrains the angle that we're dealing with, right? Based on this line definition here, the angle is fixed. For the problems in the previous video, we were given a point to start with. So we took that point and connected it to the origin and got a line which constrained the angle, and then we made a right triangle from that point. But here we don't have a point, we just have a line, so we need to choose a point. But that point can be any point we want on this line. It doesn't matter. We're going to get the same values for the trig functions of this angle. And I give specifics on why exactly this is in the previous videos. So, okay, let's pick a point that results in a nice whole number. So we can see that if we pick x is equal to minus 3, 1, 2, 3, we should get y is equal to 5. 1, 2, 3, 4, 5. So let's use this point. So this is the point minus 3, 5. Now we want to create a right triangle with this being the hypotenuse going from the point to the origin, but then the right angle needs to be connected with the horizontal axis. So we want to do this. Okay, now let's label the sides. This side is minus 3. This side is positive 5. Now we want to calculate the length of the hypotenuse, which is the radius. So the radius is going to be the square root of the side, the sum of the square of the side lengths. So 5 squared is 25, minus 3 squared is 9. Square root of 34. Okay, so now we have everything we need to go ahead and calculate the trig function values. Sine of theta, so we're not going to be able to calculate what theta is. We don't have the tools to actually calculate theta right now, but we can still find what, like, the sine of theta is, what the trig function values of theta are. Theta is a specific angle. It's fully constrained. This is not a variable. This is a specific angle. So sine of theta, we come to this angle within the right triangle, and we do the SOHCAHTOA method, but we just keep in mind that these side lengths could be negative. So opposite over hypotenuse. This is, okay, opposite over hypotenuse is 5 over root 34. Now, if we rationalize this, we're going to get, so root 34 over root 34, multiply that times this, and you get 5 root 34 over 34. Okay, now cosecant theta is the reciprocal of this, but we don't want to have to rationalize again, so let's come back here. Sine is opposite over hypotenuse, so we want to do hypotenuse over opposite. Okay, cosine theta is adjacent over hypotenuse, so minus 3 over root 34. If we rationalize this, we're going to get minus 3 root 34 over 34. Okay, now secant is equal to the reciprocal of cosine, so adjacent over hypotenuse, we're going to get hypotenuse over adjacent, minus root 34 over 3. Okay. Tangent of theta is equal to opposite over adjacent, so minus 3 over 5. And then cotangent of theta is the reciprocal of this. Okay, so we've got y is equal to minus x, but only when x is greater than or equal to 0. So, okay, it's going to be the first or the fourth quadrant. So we want to go, so we can't go in the minus x, so we'll do minus y plus x. Okay. So that constrains theta. Now let's pick a point. We can use this point. That's going to be 1, 2, 3, 4. So 4 minus 4. Okay, let's create the right triangle with the leg, with this perpendicular leg here. That the perpendicular is attached to the horizontal axis. Okay, now let's label the sides. That's going to be 4. That's going to be minus 4. Now the radius is, so 4 squared is 16. This is root 32. 8 times 4 is 32. Okay, so you've got 2 root 8. But yeah, so we can go do this again. So we have 4 times 2. So this is 4 root 2. Okay, so the sine of theta, come to this angle, opposite over hypotenuse, minus 4 over 4 root 2 is minus 1 over root 2. Multiply by root 2 over root 2, that's going to be minus root 2 over 2. Okay, cosecant theta is not opposite over hypotenuse, but hypotenuse over opposite. That's going to be minus root 2. Cosine theta adjacent over hypotenuse, so that's 1 over root 2. So it's going to be positive root 2 over 2. Secant theta, hypotenuse over adjacent, so positive root 2. Tangent theta is opposite over adjacent, so minus 1. cotangent theta is adjacent over opposite, so minus 1. Okay, so we've got the line y is equal to minus root 3x. So, and we're restricted to x is less than or equal to 0, so it's going to be the second or the fourth quadrants. Root 3 is 1.73. So let's do minus 5. Okay, so the slope is minus root 3. So we want to go minus 1.73 in the y. It's rise over run, so 0.5, 1, 1.5, so around here. And then in the positive, so okay, no, we need to do minus in the x. Positive y, so 0.5, 1, 1.5, about 1.7, and then minus y, 1. Okay. Like that. Okay, so that constrains the angle. Okay, now let's pick a point. So let's do x is equal to minus root 3. And that means that y is going to be equal to positive 3. So 1, 2, 3. There's positive 3. And so there's minus root 3. So this point is minus root 3, 3. Okay, let's create the right triangle. So we've got minus root 3 and then positive 3. Now what is the radius? So root 3 squared, or minus root 3 squared is 3, and then 3 squared is 9. So 12 is 4 times 3, so r is equal to 2 root 3. Okay, so sine of theta is equal to, come to this angle, opposite over hypotenuse. So 3 over 2 root 3, that's, so root 3 over root 3, you got 3 root 3 over, let's multiply this out. So 3 root 3 over 2 times 3, which is root 3 over 2. Okay, cosecant theta is, so not opposite over hypotenuse, but hypotenuse over opposite. That's 2 root 3 over 3. And again, usually we would just flip this, but then we have to rationalize again. So it's just, we just go back to the SOHCAHTOA mnemonic. All right, cosine theta is adjacent over hypotenuse. That's going to be minus 1/2. Secant theta is hypotenuse over adjacent. Yeah, we can just flip this, minus 2. Okay, tangent theta is opposite over adjacent, so minus 3 over root 3. So multiplying that times root 3 over root 3, you've got minus 3 root 3 over 3, so it's minus root 3. Okay, cotangent theta is adjacent over opposite, so minus root 3 over 3. Okay, for these, we're going to be evaluating quadrantal angles. All right, so like 90 degrees this is the angle, theta, right? Okay, now the way we do this is that the problem with quadrantal angles with the general definition is that we can't create a right triangle. But the way we think about it is, so like in this case, it depends on what axis you're approaching, but like just for this case, for example, we think about it like, so, let's pick this point. So this is this angle theta, right? We think about it like what happens to the triangle when we're getting really close to the vertical axis, and then once it becomes vertical. Well, the right triangle like collapses to a line, and this value of this side, the x value, becomes 0, and then the y value becomes equal to the radius, the hypotenuse. Now, the only other scenario is, so you're going to have one of the side lengths going to 0, like depending on if you're approaching here or here or here, wherever. One of the side lengths is going to go to 0, and then one of the side lengths is going to be equal to the hypotenuse. But that side length could be negative, though. So let's say we were approaching like here. Here's the right triangle. Here's the angle. Once we become vertical here, yes, the y is equal to the radius or the hypotenuse, but the coordinate of the y is negative. So we have to be aware of that. Okay, so what is the cosine of 90? Well, cosine is adjacent over hypotenuse, right? The hypotenuse the radius is always just going to be the radius. It's going to be just the positive radius, depending on the point you choose. But, okay, what happens to the adjacent for the case of 90 degrees? Well, it becomes 0. So cosine of 90 is going to be 0. Okay, secant of 180. We can think about this like the angle is, let's say we pick a point here. The angle is approaching 180. What's happening once it gets to 180, what happens? This y coordinate goes to 0. And the x coordinate and the negative x coordinate equals the radius, but it's negative x equals the radius. The negative x coordinate equals r. So it's like negative r equals r. All right, now what is secant? What is secant the reciprocal of? Well, it's not cosecant, which is sine, which is confusing. It's cosine. So this is one over cosine 180. Cosine 180 is, we don't have to look at it that way. So it's opposite of cosine. Cosine is adjacent over hypotenuse. So this is hypotenuse over adjacent. So the hypotenuse is r, and the adjacent is minus r once you get to 180. So this is going to be minus 1. Okay, cotangent of 540. So what is, that's past 1 revolution. So 540 minus 360 is what? 180. So we go 360 and then we go 180. So it was just like the previous problem. Okay, so cotangent is not opposite over adjacent, but adjacent over opposite. So that's going to be, adjacent over opposite. When theta is equal to, when it gets to this 180, which means, or when it gets to 540, the adjacent's going to be minus r. And what's the opposite going to be? That's going to be 0. So this is going to be undefined, or sometimes they'll put infinity, that we can do negative infinity. Okay, 1800. Let's see. So what's 1800 divided by 360? 5. So it's exactly 5. So, okay, so this is like 360 degrees. It's like we're doing this. Let's choose this point here. It's like we're doing that. It's like we're coming in. There's theta. So what happens once we get to 1800? The y goes to 0 and the x approaches r. Like it's positive. X approaches positive r. So sine is opposite over hypotenuse. That's going to, once it gets to 1800, that's going to be 0 over the hypotenuse is just always r. So it's going to be 0. Okay, cotangent of 1800 again. So, all right, what is cotangent? Not opposite over adjacent, but adjacent over opposite. So we're dividing by 0. And we can say that the adjacent is going to be x is approaching positive r. So this is approaching r over 0. That's positive infinity. So it's undefined, but we can put positive infinity. Okay, minus 900. So 360 times 2 is 720. I think, is that right? Yeah. Now, what is 900 minus 720? 180. So we go in the minus direction twice, and then we go 180. So we're doing this. We're coming in here. Right, it's like we're doing that. So as theta gets to the horizontal, the y is going to 0, and the x is approaching minus the radius. Like the x is the negative x is going to be equal to the length of the radius once we get to minus 900. So cosine, we come to this angle. Cosine is adjacent over hypotenuse. So you're going to get adjacent is going to be the minus x is going to be minus r over hypotenuse. So we're going to have minus 1. Okay, if n is an integer, n times 180 represents an integer multiple of 180. 2n plus 1 times 90 represents an odd integer multiple of 90 degrees, and so on. So with that, determine whether each expression is equal to 0, 1, or minus 1, or is undefined. So we can bring back the coordinate system. That might be helpful. All right, so an odd integer multiple of 90. So that's saying, like, n is equal to 1. You've got cosine of 3 times 90. N is equal to 0. You've got cosine of 90. N is equal to 2. You've got cosine of 5 times 90. So like you've got 90, or you could do 3 times 90, or you could do 5 times 90, or if like negative 1, you would have negative 90. So it's going to be an angle that corresponds to either the positive vertical or the negative vertical. Now, what does that mean with respect to cosine? Cosine is adjacent over hypotenuse. So you're always going to have the x value of the right triangle is for either case is going to be equal to 0, and the hypotenuse is going to be always positive. So this is going to be equal to 0. Okay, tangent of n times 180. So you would have like tangent of 1 times 180, or tangent of 0, or tangent of negative 180, or tangent of 2 times 180. So you're either on the horizontal, either in the positive or negative direction. So what does that mean? But when it comes to tangent, that's opposite over hypotenuse. Well, the opposite is always going to be 0 in either case, right? The opposite is the y value. That's always 0. Opposite divided by adjacent. The adjacent could be positive or negative depending on the n, but it's still going to be 0 in the numerator no matter what. So this is going to be equal to 0. Okay, so we just did an example like this, but it was with cosine. So we're on the vertical, either the positive or the negative vertical. Okay, so in that case, it's the horizontal, it's the x value like that's going to 0, right? As we get to the vertical, it's always the x value that's going to 0. So if you think opposite over adjacent is tangent, so this is going to be undefined. Now it'll be, well, no, okay, I was thinking that it might be positive or negative infinity depending on the n, but I think it would be, so here, opposite over adjacent, you would have, it would be opposite would be positive radius divided by a tiny negative number, but in the positive range. So that's positive infinity. If you did negative 90, that would be when n is equal to negative 1, you'd be coming in here. So you get opposite would be negative r divided by a tiny positive number. So that would be negative infinity. So yeah, it would just be undefined. And it would be positive or negative infinity depending on the n you choose. Okay, now with cotangent, and it's just, it's an angle on the vertical, you would have not opposite over adjacent, but adjacent over opposite. So it's going to be 0 over either positive or negative r. That's going to be 0. Okay, secant, that's cosine, the reciprocal of cosine. So the reciprocal of cosine is adjacent over hypotenuse. So hypotenuse over adjacent, this is going to be undefined. Right? Adjacent is going to 0, whether or not you're approaching here or here or here or here. The adjacent is going to 0. Secant is hypotenuse over adjacent.